All right, so moving on from slate, we're going to now talk about the next levels of metamorphic rocks. They are called schist and gneiss, and you have examples of them in your kit. I also have some larger examples here so you can get a better idea if the hand sample you have isn't quite large enough. So this is an example of schist. And schist is a very easily identifiable rock because it typically has this mica in it. So if you guys remember, we talked about micas as being important for noticing in rocks, and this is one of the reasons. You can see all this flaky, shiny material, and that is muscovite mica. You can also see that the layers, the foliations in this rock is kind of bending around minerals. So what we have is a lot of heat and pressure that's actually altering these layers. So we have more heat and pressure here than we do in the slate example. The daughter rock of the schist is likely conglomerate or sandstone, one of the two. Okay? The final amount of heat and pressure, the highest amount in heat and pressure, results in what's called a gneiss. So we have slate as the low, schist as medium, and these are both medium to moderate, but in order of going up. We have slate, schist, and then gneiss, which is spelled funny, G-N-E-I-S-S, as the highest amount of heat and pressure that's been exhibited. So gneiss is characterized by what's called gneissic banding. And gneiss, you can see these bands of minerals, these are also micas, that have actually moved within the rock because of the amount in heat and pressure. They have moved and congregated together. So the platy minerals are in layers, and those layers, again, are called foliation. So what is this rock used for? You guys know what gneiss is used for? If we think about the physical, sorry? Not necessarily countertops, that's more of a granite, yeah, but granite can certainly become gneiss through metamorphism. And it looks similar, so you're heading in the right direction. So if we think about the physical properties of this gneiss, would this be a hard rock or a soft rock? Hard. Super hard, because it's been through all of that heat and pressure, so it would take even more to become even harder. So it's a very hard, durable rock. What's something that we use and need durable rocks for? That we use every day? How about gravel in parking lots? Is exactly right. Yeah. So just because a rock is not used for an aesthetic reason doesn't mean that it's not important. In fact, it's more important a lot of times. This material, because it's so abundant and it doesn't have a real aesthetic need, can be used for concrete aggregate, gravel, fill material. It can be used for the material we saw as velocity stoppers in creeks if we want to slow down erosion. So again, what I'm trying to impress upon the students and you guys is that the physical properties of these rocks always need to be taken into consideration so that we know what they can be suitable for in everyday life.